So this is problem 5 in the mock. This is a quite a hard problem, right? In fact, I would term it a very hard problem. So you should not be worried if you see a problem like this when you're preparing for the exam, right? So it's a tic-tac-toe board, right? And I'm sure all of you have played tic-tac-toe at some point of time in your life. So I hope you know the rules for determining who the winner is. I'm not going into that. So you have to look at the three rows, the three columns, and the two diagonals. So if you have three, if all three positions in either row, column, or diagonal are occupied by the same symbol, then that player has won. Okay. So how do we go about determining the winner? Okay, this can be quite hard. Right. So you have to return -1 if there is no winner. If not, you have to return either X or O. That's why the outcome is either a string or an integer. I'll delete this, and what I'll do is I'll just write down a series of functions. But before that, few things that I would like to define. So I'm going to define what is called a pattern. Pattern is going to be a list. Okay, it's going to be a list such as this. So what do I mean by a pattern? The pattern could be either one of the three rows, or it could be one of the three columns, or it could be one of the two diagonals. Okay. So my goal is to extract all possible patterns from the board. So how many patterns are there? So you have three rows that will give you three patterns. You'll have three columns that will give you another three patterns, and you have two diagonals. Okay, so that will give you another. So that will give you two patterns. So there are 3 plus 3, 6 plus 2, 8. So there are totally 8 patterns or 8 sequence of symbols that you have to look at. And if any one of these symbols has if all three elements in any one of these symbols is identical, then that player has won. Okay, a winning pattern will be, for example, a winning pattern for X will be something like this, right? Three of them in a row. Okay, this winning pattern could come from a row, column, or diagonal. So my task now is to get hold of all these patterns and store these 8 patterns in a list. Okay, that's going to be itself another list. So it might look something like this, right? This is one pattern that goes inside this list. Another pattern could look like, say, something like this. So there'll be 8 such lists in patterns. Okay, my task is to generate patterns, okay, in some other part of the code, and then see if I can find out the winner from looking at the list patterns. So I'll do that part first. So assume that somehow I have found out all the patterns in the tic-tac-toe board. So what do I have to do? I have to iterate through each pattern in this list patterns. There are 8 of them, right? So if a pattern looks like this, 3 times, right, x, 3x's in a row, then I know that x is the winner. Else, if the pattern looks like this, I know that O is the winner. Okay. Now I have to make sure that I don't hastily return, else return -1. No, I should not do that, right? I have to look at every single pattern. Only then I can come to the conclusion that the game is a draw, right? So I have to look at each pattern. All Once I have looked at all 8 patterns, if I don't find any conclusive winner, then I know that the game is a draw. Okay, now you have to assume that the tic-tac-toe board will be proper, right? Proper in the sense you won't have two different winners, right? So we'll make sure that the test cases are proper in that sense. There'll be only one winner. So I hope you understand this tic-tac-toe board function, okay, where once you have all possible rows, columns, and diagonals put inside the list pattern. So that's what I'm calling a pattern. So each pattern could be a row, it could be a column, or it could be a diagonal, right? So there are 8 patterns in total. So there should be patterns. Okay, now this is the function that we have written. Now all that remains is to find out each of these patterns. Let's look at row patterns. So def row patterns. So a row pattern will take this board as input, and the index of the row, let me call it R. Okay, so the row index is fixed at R. So how do you extract the particular row? It's very simple, right? It's just board of R. Remember that the board is a list of lists, right? It's a matrix. Okay, the board itself is a matrix. Let me go and get hold of one such matrix, or in the test cases, okay, so this is how it is going to look like. Okay, so the board is going to look like this. So let me take some time to define this. This will be the second element, this will be the third. Okay, this is the first row. Okay, the second row will look like this. So it'll have something like this, and the third row will look like x o x. Okay, this is a list of lists, this is the board. So if you, and it visually it looks something like this, right? If you are not getting the hang of how it looks in a 2D grid format, this is how it's going to look. Now if you want the row at index 1, what do? You just get hold of the second list inside the outer list. Outer list is board, board of 0 is this, board of 1 is going to be this, right? So you just index into the list board, you will get hold of the row. That's a row pattern. Now how do you get hold of a column pattern? You pass the column index. So now you have to somehow iterate over the rows and columns. There is no escaping this. So assume that the column is going to be stored in a list L. So for I in range of the number of rows, that is length of board, right? So the number of rows is going to be length of board. For j in range of the number of columns, since it's a square matrix, that is also going to be length of board. So I'm allowed to do this, right? I'm allowed to use columns also as length of board, because this is a square matrix, right? Be careful about that. If it's not a square matrix, you can't just plug in length of board in both the cases. Okay, so what am I doing? In fact, I don't need to iterate over both, right? So let me correct myself. So I made a mistake. I don't need a nested loop. Why? Because the column index is fixed. So board of, there are two values, right? So the row index, column index. Column index is fixed at C. So I only need to iterate over the rows. Okay, remember, so column, let's say this is C equal to 1, then this will be board of 0 1, board of 1 1, board of 2 1, right? So that's what we are doing here. We are iterating over the rows alone. And I'm going to append each of them to a list. Okay. So this is a column pattern. I can finally return this column. Now the diagonal pattern, right? So diagonal pattern, this is board comma. So let me call this one diagonal. So this is the main diagonal, that the one that we are used to. So how do we return this? Notice that for all diagonals, the row index is equal to the column index. So again, I set L equal to the empty list, and for I in range of length of board, what I can do is I can just append. What do I have to append? Board of II. Okay, so what do I have to append? Board of II, that will, and then I can return L. This is the main diagonal. Now I need to return the other diagonal, right? One which goes from top right to bottom left. I'll call that the anti-diag. So this is anti-diagonal pattern of board. This is again starting with an empty list. Now notice the pattern here. So you go from row 0 all the way till row 2. So row 0, row 1, row 2. And you go from column -1, column -2, column -3. So this is how it's going to look. So for I in range of, again, length of board, that remains the same. What did I just say? So row keeps on increasing. So board of I. So row starts from 0, goes till 3. So it goes till 2, 0, 1, 2. So 0 1 2, but column starts from -1 and then keeps on going back. So it starts from -1. Okay, and then what? In every iteration it should keep going back, right? So this is -1 minus I, or I'll maybe better write it as -I minus 1. So initially I is 0, so it is board of 0 minus 1, board of 0 minus 1. Then it is board of 1 minus 2, right? Minus I minus 1 is -2. And then it is board of 2 minus 3, because -2 minus 1 is -3. So this is the other diagonal. Now I append this to L. Okay, I append this to L, and I've got hold of this diagonal also. So I can now find out all patterns. Okay, so now come back to the tic-tac-toe problem. Okay, you initialize an empty patterns list. This will store all the patterns. Now, how many row patterns are there? Three, right? So that is for I in range of length of board, because there are length of board is three. So what you might have figured out what I'm doing here. I am solving this problem for a generic board actually. Okay, so not just a 3 cross 3, but it will also work for n cross n board, provided we change this. I'll come back to that, but stick with me for now, right? If length of board is confusing, think about this as 3, right? So there are 3 rows. So for I in range of 3, I need to get hold of all rows. So that's row pattern of board comma I, right? That will give me the ith row, right? Assuming zero indexing, so that will give me that row. This is one pattern, right? This is one row pattern, so I'm going to append this row pattern here. Okay, so I am now appending one row, okay, to patterns, and I have to do this for all rows, right? I also need to do this for all columns, so I do patterns dot append column pattern. Okay, that's column pattern of board comma I. Okay, so that's going to append the ith column. Now I need to append the diagonals, right? So that's main diagonal. So main diag of board, and then patterns dot append of anti diag of board. Anti diag of board. Okay, now I have all patterns stored in my list patterns, and then I go and iterate through each pattern. Okay, this will work only for this line number 35, right? Will work only for a list, a board of size 3 cross 3. So if I want this to work for a board of size n cross n, I need to multiply this by length of board. So I'll just quickly explain what I mean by that. So what happens when you multiply capital X with 2? Okay, you'll end up with the list where X is repeated twice. Okay, like therefore if you multiply this with 4, you will end up with X repeated 4 times, right? So here what are we doing? We are multiplying it with the length of the board, or the number of rows or number of columns, and for this particular example it's 3. Okay, so that's what this multiplication does. So likewise I can go back here and change this to into 3. Okay, now that completes the function, but we can't be sure, there might be some error, so let's go ahead and submit it. Okay, so yeah, as expected, some error has crept in. Let's go back. Is it a syntax error? Okay, it's a name error here. So it's telling us that main diag is not defined. So what did I? So it was main underscore diag underscore pattern. Okay, so the pattern is missing in both these places. So there should be a pattern, and so this was totally wrong. Okay, so I'll just change this. So there should be an anti-diag pattern where board is passed as an argument. Okay, so there were 2 errors. Let's see if that has fixed the problem. Okay, so 5 out of 5 private tests have passed. Okay, so let's go back. I'll quickly summarize what we have managed to do. Focus on the tic-tac-toe board, okay? And for now, forget this loop. So what do I call a pattern? What I call a pattern is any row, column, or diagonal. Okay, so a pattern is going to be this. So let me change this to length of board. Okay, so that's a pattern. So I am here, this part of the loop is of the code is still testing who has won. Okay, that's the main part, right? So it's testing who has won, and the way to do it is to check if the pattern, which could be a row, column, or diagonal, if it has a string of x's or o's. Okay, so that's done by this if and this else if condition. Okay, now after testing each pattern, if none of them satisfy this condition, that means no winner is there, so it's a draw. I return -1. That is this part of the code. The remaining part of the code is what? It is trying to get hold of all patterns. So I need to get hold of all row patterns, all column patterns, and all diagonal patterns. That's what this part of the code is doing. The first 25 lines are essentially get extracting the rows, columns, and diagonals. So how do you extract the rows? This is how you do it, because it's a list of lists, right? A matrix. So you can directly you can directly use the row index and get hold of the row. Column pattern is slightly difficult. You have to iterate over the rows while fixing the column index, okay, and then return the list of elements in the column. The main diagonal, you have to use the fact that the row index and column index are the same. For the anti-diagonal, the other diagonal, you have to use the pattern that the rows keep increasing and the columns, if you use negative indexing, they keep decreasing starting from -1. Okay, so therefore this minus I minus 1. And finally, if you orchestrate all these different functions and put them in tic-tac-toe board, it will give you the expected result. So as I just conclude by saying that this is a very hard problem, okay, from the context of the exam. So you don't need to worry about this if you're not able to grasp this in one go, okay. So that's the end of the solution to PP, the mock problem 5.